Assalamu alaikum, brothers and sisters. It's TKE Safety Ambassador, and today I'm going to be testing my hydraulic power unit. Now, I fixed it. As you can see, this is the main jack outlet inlet. Tank. Pump means this is going into this adapter. It's going out of this adapter. So, yeah, I've screwed it in, made multiple holes. That's okay. I'm going to be using this as my solenoid valve opener and closer. This was going to be a soft starter until I just realized that when I tested it multiple times for frequencies would not output because it was supposed to run 60 hertz through the solenoid electromagnetic coils for slow speed. Because it will slow down the speed and I want it to be a little slow. I don't want it to be fast. We just opened the down valve. We could close our hydraulic shut off completely. Close our down completely. When you hear it click, when you reverse it, it will open. When you reverse it again, it will close. But to open it, it has to be on the exact polarity to be open. It's the thing with this valve. It's a water-powered hydraulic. So these are water-powered hydraulics. Haven't done this type of hydraulics in a while. Apparently the machine room is going to be exposed and out in the open, meaning it's going to be on a roof. It's going to be on the highest floor of my sister's dollhouse. She cannot have it on the lowest floor because, out of respect, she has stuff down there and we don't want to disrupt her stuff. Apparently, these are the wires we're going to need to connect. This is our positive wire. I don't know why it's bent like that. Put in our start-stop wire along with our negative. This is our PWM. We do not need to connect it unless if we have a frequency source. And this pump will not be having one temporarily. It's for testing purposes. Running the pump with no actual frequencies we could hear. These are the highest frequencies from the power supply. So it's got enough PWM, like the built-in PWM from the power. You can hear it trying to prime. You can hear it bleeding. There it goes. And when it silences like that, when the valve closes, the diaphragm pump will stay on. Now, if it needs to release a little bit of pressure afterwards, it will go up a little bit. Then it will have to go down a little bit, and I don't know how I'm going to do that. It's going to have to go down a little bit on its own at least, like only for a split second. So now we are going to actually send the car down completely. Connect your voltage as displayed, positive and then negative to open. Once you hear a click, the valve is open. We can send the elevator down. You can hear it go back into the tank. Now you will be able to hear water noise, but I've tried to minimize the noise. You will hear it a lot in the cylinder, unless if you have something blocking it. If it was on a very lower voltage and closing like that, I don't think it would be closed all the way, because it's still at least. We close the valve. Now we're going to go up one more time. Now we close our solenoid. We close it. So nothing's going to go through. Basically, I did have a problem where it was leaking, but that's not happening anymore. Like I said, these are really good valves. I'm glad I have them. You can see on the top that it is spinning. You cannot really tell much. But if I had something on here like a taller shaft, you would be able to tell. But you could tell because of the vibrations it makes when it starts. And when we open our down valve, what's going to happen? It's going to go back into the tank. We'll at least release a little bit of pressure. You can hear it slowly opening. It doesn't slowly open. It immediately opens. Like you get this click. See, it's not going down. If we were to go down on it like that, it's going to blow the packing. Now, there's a little leak down there. It's not important. It only happens at certain times. If it were to go down like this, it would first of all blow this out. But if it had this seal in, it's going to blow the packing completely. We do have a little leaks on the cylinder, top and bottom, but not on the valve assembly and the pump assembly. Now, the water goes into this diaphragm pump, and it's a very high pressure diaphragm pump, so the elevator is only going to go up slowly. It's not going to go that fast. I will find there are multiple ways I will be getting this thing to go a bit faster without actually having to go over 12 volts. So look, this pump is literally a 12 volt pump. You see it says DC 12 volt. It's literally a 12 volt only pump. It's the Nidec 00H2208012 water diaphragm pump, 12 volt. They do have a 24 volt version of this. They do have one without the PWM and or the start stop or speed monitoring or frame ground. But you could tell this is white start stop, red positive, black ground or 12 volt ground. Start stop normally closed. Frame ground start stop normally closed, not required. Maybe it goes into the start stop. Never tested it out. And this is PWM. There is no speed monitoring wires on this. So when we turn on our pump, there are no valves open. So I just closed all the valves. I'm gonna now open up the up solenoid. Closing. See, it's closed. And you can see the seal a little bit, but it is not leaking. We're not getting air bleeding from it at all. It's gotten to the top enough. It's going to get up to. It's got a very strong hydraulic force. And I don't want to go ahead and break it. You see, we're getting a little leaks from that. If we were to keep it like that, it's going to bust. Might as well just shut it off. Put our back in. Alright, now we're going to shut off the whole pump. The diaphragm pump shuts off. A little bit of pressure will have to be let out. Then, we will be able to let that pressure completely release immediately. Once we do this, you'll be able to get a listen. So you could definitely tell some water got in because it vibrated a lot. Now the solenoid's active at this point, but it's going to be continuously running on voltage while it's going down to ensure proper speed. Now the solenoid will be able to take the elevator car down. We have to open our valve. You can hear the water go back in.